So in this video, we're going to go over the problems that are in the Unit 4 test review. So let's rewrite 6 to the third equals 2x minus 1 in logarithmic form. So remember that this is b, this is x, and this is a, right? So if a equals b to the x, that means the log base b of a equals x. So we can also rewrite it using the arrows. We can say the log, the base is going to be the same, right? It's still going to be 6. So we think about the arrows backwards. This is like 6 to the third equals 2x minus 1, right? So that means that in logarithmic form, this is the log base 6 of 2x minus 1 equals 3. And that is our answer. So now let's work on this problem and solve for x. We have 13 to the 3x equals 56. So the term with a variable is already isolated, so we're going to go ahead and take the log of both sides in order to solve for x. So we have log of 13 to the 3x equals the log of 56. So I'm going to use the power property and bring that 3x down in front. So I have 3x log of 13 equals the log of 56. Now I'm going to divide the log of 13 on both sides in order to work on getting x by itself. So when I do that, I get 3x equals the log of 56 divided by the log of 13. So now in order to solve for x, I need to divide both sides by 3. And so when I do that, I get x equals the log of 56 divided by 3 log of 13. So now if I was finding an exact answer, this would be my answer and I would be done, right? But in this problem, it wants us to approximate with a decimal, so we're going to need to do this on the calculator. So we're going to do the log of 56, okay, and then hit enter, and then do divided by, and then what I'm going to do is I'm going to put this denominator in parentheses, okay? So make sure you put that denominator in parentheses so that the calculator doesn't get confused and give you a wrong answer. And so when you do that, you should get x is approximately 0.5231. So in this problem, it says a savings account starts with $526. After 10 years of continuous compounding at an annual interest rate R, the account has $2,435. What is the annual interest rate expressed as a percentage? Round your answer to the nearest hundredth. Okay, so whenever it says continuous compounding, okay, that's the key word. That means that we're going to use that A equals PE to the RT formula. Okay, so A is the final amount in the account. So that's that $2,435. P is the amount that you start off with, right? It's the principal. So that's $526. And then R is the value that we're going to find, right? R is the interest rate we don't know. And then T is the amount of time, which is 10 years. So now let's plug everything you have into this formula, and we have 2435 equals 526, and then times e to the r times 10. Okay, so that means 2435 equals 526 e to the 10r. So now we need to solve this equation, so we're going to go ahead and divide both sides by 526. So when we divide both sides by 526, we have 2435 over 526, and that equals e to the 10r. So now I have an e, so the way to get rid of e is to take the natural log of both sides, right? So I have the natural log of 2435 over 526, and that equals the natural log of e to the 10r. So now what I'm going to do is I'm going to use that power property to bring that 10r down in front, okay? So I have the natural log of 2435 over 526 equals 10r natural log of e. Well, the natural log of e is just 1, okay? So this tells me that the natural log of 2435 over 526 equals 10r. And then now to solve for r, we're going to divide both sides by 10. Right, so we're just going to divide both sides by 10, so I can just put all of this over 10. So that means that r is the natural log of 2435 over 526, and that's all divided by 10. Okay, so let's just go ahead and do this on our calculator now. So we have natural log of 2435 divided by 526, and then close the parentheses and hit enter. Then do divide by 10, and that should give you 0.15324. Well, notice that it asks for the interest rate expressed as a percentage, right? So we're going to move the decimal 2 places to the right, and it says round to the nearest hundredth. So we have 15.32%, okay? And that is the value of R. So in this problem, it says, what is the exponential form of the logarithmic equation 3 equals log of 0.2, log base 0.2 of 0.008? Okay, so I'm just going to rewrite this just so that we can draw our arrows in. So I'm going to write this as log base 0.2 of 0.008 equals 3. Okay, all I did was move the 3 to the other side. So now I can draw in those arrows, which will help me write it in exponential form. So I have 0.2 to the third equals 0.008. Okay, and that is the exponential form of this logarithmic equation. So now let's go ahead and work on this problem. It says x equals the log of 635 and round your answer to 4 decimal places. All you need to do is type this in your calculator. Just do log 635, hit enter, and then we have 2.802, and then that's going to round to an 8. Okay, so you just use your calculator because that is the common log. Now it says to solve the logarithmic equation, y equals the log base 7 of 343. So I'm just going to turn this equation around so I can draw in those arrows. And so if I write this in exponential form, this tells me that 7 to the y equals 343. So remember, I'm going to use that powers chart to see if I can write this using the same base. And notice that 343 is actually a power of 7. So this tells me that 7 to the y equals 7 to the third. Well, remember, if I have the same base, that means the exponents are equal to each other, right? So that means that y equals 3, and that is my final answer. So in this problem, it says, what is the exact value of x? Okay, so what we need to do is we need to get that term with a variable by itself. Well, we have 5 times 3 to the 2x. So I'm going to start off by dividing both sides by 5 in order to get that 3 to the 2x by itself. So I have 3 to the 2x equals, and then I do 138 divided by 5, and that gives me 27.6. So now in order to get that exponent down, I need to take the log of both sides. So I have the log of 3 to the 2x equals the log of 27.6. Okay, so I'm going to use the power rule now to bring that 2x down in front. So I have 2x log of 3 equals the log of 27.6. Okay, now I just need to solve for x. So I'm going to start off by dividing both sides by 3. So when I do that, I get 2x equals the log of 27.6 divided by the log of 3. Now all I need to do to solve for x is divide both sides by 2. And so when I do that, I get x equals the log of 27.6 divided by 2 log of 3. Since it's asking us for an exact answer, we're just going to leave it like that. Okay, we're not going to type it into our calculator and round or find a decimal or anything. It has to stay like that if they want the exact answer. Okay, so now it says what transformation takes f of x equals the log base 3 of x to g of x equals the log base 3 of x minus 5. Okay, so the question is this 5 a value of a, b, h, or k? Well, notice it is outside the log, right? So if it was inside the log, it would have looked like this. Okay, there would have been a parentheses around it. But since we don't have that, it's outside the log, so it's going to be a value of k. When k is less than 0, it shifts down. So what happens is that minus 5 is going to create a shift down 5 units. Okay, and that is the only transformation that we have in this problem because that's the only new number that's been added in. What happens if f of x equals the log of x is transformed to g of x equals 2.7 log x? Identify the parameter and the effect it has on the parent function. Well, the new parameter, right, the new thing that we have here is that 2.7. So that's what they mean by parameter. What's the new stuff? So that's that 2.7. And let's think about what it is. It's in front of our log and it's multiplying, right? So that's a value of a. Well, it tells us if the absolute value of a is bigger than 1, that is going to be a vertical stretch. Okay, so that is going to be a vertically stretched log function. So in this problem, it says, which graph represents f of x equals -3 log of x plus 5 minus 1? So the best way to do this problem, I think, is to just go ahead and graph this in Desmos and then look for some points on the graph. So those points will give you an idea of what to look for when you're looking at these multiple choice answers. Okay, so now here I am in Desmos, so I'm going to go ahead and type in this function. So -3, and then I have log, and then that's going to be parentheses, x plus 5, close parentheses, and then minus 1. Okay, so now if we look at this graph, we kind of get an idea of what it looks like, okay? So notice the shape of the graph. It kind of curves down as we go left to right. So that's going to be an important clue in trying to figure out which one is the correct graph. Another thing I like to use is I really like to use the intercepts, because if you click on those in Desmos, that will give you the coordinates. So we have the intercepts at -4.536, and that is the x-intercept, and the y-intercept is going to be at 0, -3.097. Okay, so now let's go back to our problem and see which multiple choice answer matches. Okay, so we're looking for a graph that has an x-intercept at -4.536, 0, and it has a y-intercept at 0, -3.097. Okay, so let's look at these graphs. And remember, we said that our graph kind of has this like curving down shape, right? So we can automatically eliminate C and B, right? They don't even look like our graph. Well, we want a negative x-intercept. So notice that in A, the x-intercept is between -4 and 5. Okay, if we look at D, it has a positive x-intercept, so that kind of gives us a big clue that D won't work. But let's just double check. Let's go back and check the y-intercept also, and you can see that the y-intercept is a little bit below -3. Okay, so that's why A is the correct answer. So always remember when you're working on those graphing questions to use Desmos to help you out.